If you are a developer, especially if you are dreaming building your own SaaS system, here is something you really need to know. No matter what you build, your system always will have an architecture. But here is the danger. If the architecture is not shaped or dictated by the non-functional requirement of your system, then guess what? Your system will not probably run beyond your local machine. It may work in dev, it may even demo fine, but the moment it gets real user, real traffic, and real data, boom, it crashes. When you design, every architectural decisions you make is guided by the non-functional requirement of your system. Your job is to analyze those trade-offs of your requirement and the business story. That's the real battle of real engineers face. Do you optimize for your speed or for cost? Do you design for flexibility or for raw performance? Or do you go military guide security or lightweight so you can move fast? Those decisions or those trade-offs define the system, not the feature lists. Let me give you a real example. I was once asked to build web-based betting platform where live games will players join and play. The first thing what I do was like most developers do, I asked the client a question, okay, what features do you need? And the client reply was, for now start with bingo, but later I need some games like Ludo, chess, and more. So I jumped into researching for how bingo works, the rules, the logic, and all the detail. But here's the key difference. I didn't just jump to open VS Code to start coding or to implement those logics. Instead, I started digging into the non-functional requirement of the system. I asked questions to demonstrate, to figure out those non-functional requirements. My first question was how real-time this should be. Since it's a face-to-face betting platform, obviously it could be as much as possible, but I need to tell you here that everything you have to ask the client before you figure out or decided in some architecture. So that was my principle. So I asked it real-time and the reply was real-time as possible. Boom. So here I realized that this is the first non-functional requirement, which is low latency. So I note that in my non-functional requirement list. And the next question was, what happens if the game crashes? I mean, it's human-made, so maybe the server may go down. So my first question was, how do you compensate or how do you take it if the game crashes? All the live games lost, and do we refund for everyone, or what should we do? And the client's reply was, this can never happen. It must be really resilient and reliable. So now I figure out two non-functional requirements, which are the fault tolerance and high availability, no downtime. Then I also asked it other questions like, how fast do you need to complete this project? This is also part of non-functional requirement. Most people did not recognize or did not accept it as a non-functional requirement. This is the critical non-functional requirement of the system. How fast do you need to complete this project? And as response from the client was, as much as you can. I need this to be fast as you can. And here I figure out the critical non-functional requirement, which is rapid delivery, or mostly we call it time to market. And the other question was, how many live games or players do you expect from this system? So this related emphasizes for the scalability of the system. So obviously the reply from the client was, it should be global wide, anyone from anywhere. That give me more scalability, or the system will have much as can be scaled. And the last question was, what about new games ladder? I mean, do you need to add? Obviously, he said definitely. So this give me extensibility as a non-functional requirement. By just asking the right questions, I had already discovered the most architectural drivers, and none of those came from the features. Rather, they came from the non-functional requirement of your system. So now, with these requirements in head, we will start sketching the architecture. Not just based on what the system does, but how the system behaves under real conditions. And that's the difference between writing code and building the system. Okay, let's start sketching our system. So before we sketch, we have to analyze our non-functional requirements. So we have to note down. The first is we need a low latency. So for not to navigate from one place to other, from one window to other window. Let's collect those things here. So our first our first non-functional is it should be low latency. Okay, what about the next one? The next one is what will happen if the game crashes?
or and so on and so forth, fault tolerance. So we have a fault tolerance and high availability. So okay, what else? What else the client needs rapid delivery and scalability in mind. That means time to market. Mostly we call it time to market. 3, comma, time to market. What else? The scalability and extendability. Okay, this in mind, we are going to sketch our system. So the first thing we have to do is sketch the first minimal working architecture of your system. So that will be very easy, which is straightforward. We have a client here, and we have a backend service here. And finally, which is we have a database. That's it. This is the first minimal working architecture of our system. This is straightforward. When a user hits the button to create a game, that will process our backend for that game, whether it's private or not, and checks everything, then it will persist it. So when any user or any player needs to fetch all live games, he will click that button and that this backend will process. He will check whether this guy is authorized or authenticated. Then it will fetch the live games from the database and forward it. That's it. But here is the problem. Our first non-functional requirement is low latency. So with that in mind, when we look at our architecture, it shouldn't obey that. I mean, you see, there is frequent call to database which will reduce the performance of our backend, even overloads our database servers, which will force us to instantiate other database. So it will cost a lot of money. So the first thing we have to do is we have to figure out if this is live game, is this any case that we have to persist whenever it is created? At the time when it's created, do we need to persist it in the database? No, I don't think so, because these live games are those games which are currently interaction with users, with a lot of users. So we don't have to persist on that database. We have to keep it in our service. So with this in mind, we have to create some module inside that will manages what we call it, live game manager. What we call it, live game manager. This module or this subsystem inside our backend service is supposed to manage those all live games. So inside here, any request to fetch the state of any given live game or to fetch all live games, we don't have to communicate with our database. So this will give time to our database, which will not overload it to our database. And this architecture also will give 10 times performance than the previous, where we have to call to the database to fetch live games. So this will increase our performance 10 times. But we do have other problem also here. What do you think so? I'm waiting you. What do you think so? Yes, that is a scalability issue. I mean, now it's very fast, and a lot of players love your system because of its very fastness, and the traffic overloaded your service. So you realize now, oh, your operations, you have to instantiate other service so that our backend service must be scaled vertically. That means, let me sketch for you. Let me sketch. Let me sketch it so you can visualize it. This, let me call it server 1. So let's duplicate it. First of all, let me group it and duplicate it 3 times. That's fine, but here this is server 2 and this is server 3. Okay, so as I said to you, we have to what? We have to scale it vertically, means we have to instantiate other services or other servers so that we can also run our applications in 3 servers, so that the load will be, and we will have actually here a load balancer. Load balancer. A load balancer. Let me group it. Okay, this is servers. That means you can say it's just a laptop which has more performance. You know server, or you can search it about server. So this is 3 servers. So this backend previously was running on 1 server, but now because of a lot of traffic hits. So now our operations look that our server was overloaded because of a lot of traffic hits our server. So they decided to scale it in vertically. So they instantiated 3 vertical, 3 servers, and ran the system on those 3 servers and put a load balancer here. Cool, yeah, instead of one server, instead of running in 1 server, we have 3 servers running the same application to serve a lot of traffic. That's cool, and you think, what's problem here? You know what? Look here, the problem is inside our system, our backend service, which has its own live game manager. This is very dangerous. That means our system becomes stateful. That means when a client or when a user creates a live game for the first time, our load balancer will forward either of these 3 servers. So let's say request was forwarded for this server, so the live game was created and managed by this live game manager inside our backend service, which is running in the server 1. Then after a while, the same user was requested to fetch all live games. So the load balancer, instead of forwarding to this because of it was loaded, I don't know, or for some case reason, it was forwarded to this because the load balancer did not forward to one server only, because it's not supposed to forward in one server. That's not his job. Its job is to distribute the request to all servers. So by chance it was forwarded to server 2. So when server 2 gets that request, it will fetch live games from this live game manager, so it will forward to that user. So he will see that his game created is missing from those live games, which will cause inconsistency, and he will also try to create another game and it will go here and so on and so forth. Or when user is joined, or when he requested to look, boom, he will get 404 because of that live game is present here, and our game will crash every time, every minute when the request is forwarded to different servers. So what will be the solution? What will be the solution? Yeah. The solution will be putting some other kind of service. I mean, other kind of, yeah, we call it service. But by the way, this is a service, and this is also a service, which we call it Redux Cache. So what this guy can do for us? That's cool. Instead of, we will not change anything. We will not change anything, but instead of having this guy inside here and manage those live games by itself, it will communicate with this guy. That's it. There is no any big change here made, but we add a caching layer. So instead of managing live games inside his memory or RAM, he will put in this Redux, and whenever he requires, he will fetch from this. That's it. So doing this, when we come to the scalability issue, when we come to here, we will have this guy. So all these are connected to this guy. This live game manager is connecting to this guy. So any live games and their status are managed by this Redux, and which is very cool. Even we can scale it within one click like this. Even if it's not such like this, but it's very simple. If you see that your Redux is overloaded, you can simply scale it like this. No need any kind of duplication. But what is the problem here? The problem is before adding this one, our performance was 10 times better before our database connection. But now it decreases slightly, but we don't give a care because of it's slightly. Even this is not persisted in database. Instead, it persists in RAM. So it's very fast to fetch the live games. So it doesn't cost us a lot of latency. So we will leave it like this. But guess what? I didn't do like this for my client. Why? Ask me why. Because it needs some configuration and some learning curve to implement this for me. That's why I leave it just like the before. Because the system was, first of all, it needs time to market. Look here. Which means even though I have to keep that Redux, but at that time I don't have any skill to integrate with Redux. That's why I didn't add that one. And I said, since it is a new system, so, and it has not have any users before, and it's new, and the client needs time to market, which is fast delivery, so I decided not to learn about Redux and implement it, and I may make a fault, or I may not handle it perfectly, or I'm like experts do. So that's why I decided let me keep it for now like this. Then whenever the client needs any scalability issue, till that I will learn about Redux and I will implement it as supposed to. That is why I leave it in memory. And because of this, any new users will experience very fast interactive system. So that's why he will get a lot of players and satisfy those players because of its performance. Wow, this very fast system. So he will gather a lot of users, and when he needs to scale that application, and because of I made it a module, it is very simple to me to add Redux and integrate with that. That's why my final architecture was this. That's it, not this one. So every day, even though this was the best solution, but I didn't use that. So from this you can look what are the trade-offs. So the trade-offs may be the time taken to deliver your time and your team's performance. If your teams don't have any skill in Redux, you may replace with RabbitMQ or with Kafka or any kind of else. So the decisions between making this system or this service from other service depending on a lot of factors, which we call it as an architect trade-offs. So thank you for watching our video, and I hope you get a lot of things. And if you have any question or if you need low level design of this system, please comment in the comment section and I will prepare the next video for you. Thank you.